So to compute C and D, what we need to do is first consider this expression and realize that when S tends towards j omega, then the expression tends towards D is equal to A h of j omega. And so, if D exists, it must be A h of j omega. On the other hand, we can now replace D by its value, and we obtain that C times S minus j omega is equal to A h of S minus A h of j omega. Or, if C exists, C must be equal to A times h of S minus h of j omega divided by S minus j omega. Or, in other terms, we must have that C is the limit when so hold on a second. So C must be the limit of A times, so when S tends towards j omega, of A times h of S minus h of j omega divided by S minus j omega. Now h is made of real coefficients in front of the variable S, so we can say that C must be equal to A times dh of S ds, the derivative of h with respect to the variable S, where that derivative is taken as if S were a real number. So, here is what we obtain. Here's the value of C, here's the value of D. I can now get, therefore, that y hat is equal to A h of j omega times 1 over S minus j omega plus A times dh of S ds expressed at S is equal to j omega. Now, what do I get? I get something having to do with, on the one hand, an oscillatory component, and on the other hand, a component which usually tends towards zero when we go in the time domain. Indeed, I will take this formula again. And I can invert it. Okay, so I can take the inverse Laplace transform of this guy. That is y of t, and that will be equal to a h of j omega times e to the j omega t plus a, the inverse Laplace transform of dh ds when s is equal to j omega. Now, this term turns out to go towards 0, and this term is oscillatory. Now, this is called the steady state. This is called the transient. The steady state component is also called the frequency response. Okay? So let's see how that works for a particular example. For that, let's pick a simple system. For example, h of s is equal to 1 over s squared plus 2s plus 1. Now, we excite the system by e to the j omega t. I will forget about a. I get that y hat, so that is u, okay? So I get that y hat is equal to 1 over s squared plus 2s plus 1 times 1 over s minus j omega. I reduce that, so the effect of writing that is this equal to c plus d over s minus j omega is very much the same as a partial fraction expansion. Okay? So what I write is that c times s minus j omega plus d must be equal, in this case, to divided by s minus j omega, must be equal to 1 over s squared plus 2s plus 1 times 1 over s minus j omega. And so what I do is I just unfold this thing automatically, like you have learned how to do now many times. If you haven't, it's time to do so. Okay? So I erase these guys, and I get quasi-automatically that d must be equal to this guy when s tends towards j omega. So d must be equal to 1 over j omega squared plus 2 times j omega plus 1. Next,